Watch the following clip of a helicopter takeoff and consider what forces are acting on the helicopter to enable it to do this. Now let's analyse the forces involved. At first, the helicopter is stationary on the ground. The weight of the helicopter is loaded on the landing wheels, which is in contact with the ground. So there are 3 contact points between the helicopter and the ground. These are where the weight vectors will act, as shown by the blue arrows. As the helicopter is stationary, then the ground must exert a force back up at each point to balance the weight of the helicopter. This is the normal force exerted from the ground. As the helicopter's main rotors increase in speed, it creates a lifting force and begins to lift the helicopter's nose off the ground. So the weight exerted on the front landing wheel is reduced. Thus, the normal force at this contact point is also reduced. When the front landing wheel is off the ground, there is no more normal force here. The entire weight of the helicopter is now on the back landing wheels. The lift force from the main rotor increases further and begins to lift the helicopter off the ground. At this point, the lifting force is equal to the weight of the helicopter, and so the upward force is balanced with the downward force. There is no longer a need for the normal force to act, so it reduces to 0. When the lifting force is greater than the weight, the helicopter will begin to rise. The acceleration of the rise will be proportional to the net upward force in accordance with Newton's second law. When the upward lifting force is balanced with the downward weight, the helicopter will remain in its current state of motion, hovering above the ground in accordance with Newton's first law. If the upward force increases, there is a net acceleration upwards and the helicopter will rise. In order to move forward, the helicopter must tilt forward such that the lift force is now pointed slightly at an angle. The lift force now has a vertical component and a horizontal component. The vertical component of the lift force must balance the weight of the helicopter in order for the helicopter to stay at altitude. In other words, the net force in the vertical direction is 0. Otherwise, the helicopter will rise if the vertical force is greater than the weight, or the helicopter will sink if the vertical force is less than the weight. The horizontal component of the lift force provides the horizontal acceleration to propel the helicopter forward. To understand how forces behave better, play the following lunar lander game attached to this module. The game is provided courtesy of the PhET Interactive Animations project. The aim of this game is to land the lunar lander on as many flat zones as you can before your fuel runs out. Don't forget to turn on the vectors so that you can see how the force and acceleration vectors change as you apply more or less thrust to the lander.